Hey everyone, welcome to this video for P8105, a course on data science. This is the second in a collection of 3 videos on iteration, the process of doing the same thing over and over and over. In the first of these videos we talked about writing functions, and now we're going to use functions to actually do that iterative process. And we're even going to see how to do that in the context of data frames using list columns. I'm going to start by giving an introduction to the material using slides. After that, I'm going to demonstrate using a screencast. Feel free to skip around to the parts of the video you find most useful, and please do code along with me. All the material is available at p8105.com, and there are links in the description. Awesome. Let's get started. All right, let's jump into iteration and list columns. So the first question is, why should you iterate? One of the things that we talked about in the first video was to write functions. Basically, if you're going to use the same code more than twice, you ought to start using a function. And that problem comes up an awful lot of doing the same thing more than twice. That comes up an awful lot. And so very often you're not just going to write a function and use it once or use it twice. You're going to end up needing to use that same function 5, 6, 7, 12, 73, 148 times. You're going to need to use the same function an awful lot of times, not to just sort of run this line of code once and then run it again, but to iterate, to start with some collection of inputs that you care about and to apply that same function over and over and over. This process of needing to do the same thing over and over and over again actually does come up an awful lot when you're working either in statistics or in data science or using computers or doing things in general. We're trying to automate those iterative processes as much as possible. So the first place we're going to start is for loops. And I'm starting with for loops both because it can seem a little bit more intuitive when you're just getting started with this idea of iteration, and also if you have any programming background at all, you've probably seen for loops a lot. So we're going to talk about this first, and we'll see some examples in the screencast, but then we're going to move into something that I think is a little bit more straightforward, and that really is my preferred approach. So the basic idea with a for loop is that you're going to have an output object, something that you want to save, right? You're going to iterate over something and you want to save the output over that. You need to iterate over some sequence. You're going to do the same thing the first time and the second time and the third time and the fourth time. Inside of your for loop, there's going to be some body of code that does the same thing that you're interested in. And very often, not always, but very often, there is an input object as well, meaning you've got your first input and you want to apply some function to that first input and then save the output and then move on to the second one and so on. Now, even with for loops, but especially with things that we'll see later on, very often it's helpful to keep track of the inputs and outputs using things that are lists. And I'll talk about R and lists in a little bit, but for now I want to sort of focus on the idea of what for loops do. So this is the basic structure for a for loop. You're going to start out and you're going to define an input, and maybe that's something that you're creating, or maybe it's something that exists in your data set somewhere else, but you've got an input and it's a list. And then you've got an output, and that's also going to be a list. You don't have that output list yet, but I'm saying here, create it in advance so that you know exactly what you're going to create. You need like an output list that's all blank. It's just got empty spots everywhere, but you're going to make sure to save whatever happens to your input into the corresponding spot in your output. And creating both of those things at the outset helps a lot. Now, the structure of a for loop sort of is the following. You're going to start out, there is some index that keeps track of which iteration you're on, and that is going to start at 1 and it's going to go to the maximum number of iterations, right? So if you've got 10 objects in your input list and 10 slots in your output list, I is going to start at 1 and then it's going to go to 2 and then 3 and then 4 and then 5 and then 6 and then until you get to 10. And each time it's going to start at the beginning of whatever code is in here. It's going to run all the way to the end and then go back to the beginning and take on that next index. So the way I would read this is first time through I is equal to 1. I come in here and I say, great, I've got input. I'm using list notation here. And again, we'll sort of talk a little bit more about this, but I've got an input list and I am accessing the first, now that I is 1, the first element of my input list. And I'm applying some function to it. And then I'm saving that in the first element of my output list. And then I go through the rest of this and there's nothing else here. Then I go back to the beginning and now I is equal to 2. Second element of my input list, apply a function to it, save it in the second spot of my output list. I becomes 3. Third object input, apply F, save it into the output list. And that's sort of the process here. Now, often your for loop, sometimes your for loop has more code in there. You haven't sort of pulled everything into a function, but I'm trying to be really clear here in the sense that if you have a lot of code inside of your for loop, you could turn that into a function, and I think that's going to be a more straightforward way to do things. But this is the structure. This is how for loops work, right? You get your inputs, you get your outputs, you have a sequence, you iterate across the inputs, applying each function, and you save the outputs as a corresponding list. And that's pretty great. Now, hey, that's pretty great. For loops are actually not my preferred way of working with things. So this whole idea of saying I'm going to supply an input list, and then I'm going to apply a function to each element, and I'm going to save the output, that is a really common structure. Input, apply a function, save an output. That's what you're looking for. The for loop structure gets a little bit tedious, and it's sometimes hard to just look at and understand. You do have to define your output object in advance. You have to know what you're sequencing over. You have to keep track of indexing I over here and I over here. You have to make sure that those sort of match up in exactly the same way. And if your functions are complicated, or the inside of your for loop is complicated, you can lose track of things along the way. Altogether, then, it's maybe not the most direct way of applying a function to every element of this list and then getting the outputs and saving it in this list. And that's where loop functions come in. The idea for loop functions is to just say, give me an input list and a function, and I'll give you an output list. And that's all there is to it. No loops, no index, no I in 1 to n or anything like this. Give me your index, give me your function, or give me your input, give me your function, and I'll give you the outputs. And the ones that we're going to use, the loop functions that we're going to care about, are in the per package. And in particular, we're going to use map and occasionally like variations on map that do kind of the same thing but clean up the output for us. Per has a sticker, and of all the stickers, like, I don't understand why it's like a somewhat poor drawing of a cat, but whatever, that's the per sticker. I'm not going to spend a lot of time talking about base R approaches to this. You might see things like L apply and S apply and M apply and some other things. In short, don't use those. They're really confusing. Use per or map for everything. And that's all I'm going to say about that. All right, so how does map work? Again, we're trying to simplify this process of iterating, and the basic structure now looks like this. Instead of having input, output, for, code, chunk, whatever, what we're going to do is say, I want an input. I want to apply this function to every element of my input, and so I am going to map this function across input vector values, input list values, and I'm going to save that as an output. Now, what map is going to produce is just an output list. I'm saving that output list into my output, and that output is the same length as my input. It's again, I think, much clearer in the sense that I've stripped away a lot of the for loop infrastructure fiddly bits that you have to keep track of, and I'm just focusing on the things that I care about. Input, function, output, the end. That's it. Now, again, the benefit here is not that this is faster than a for loop, but it should be that it is clearer than a for loop. And maybe the first time you start working with these, neither of them is going to be especially clear. But over time and with practice, this mapping approach is just a lot clearer than writing a sequence of for loops. Okay, so like I say, there's some variations on map. Generally speaking, map is going to take an input list and spit out an output list. If you know that output list is all going to be numbers, you might want to just say, don't give me a list. Lists are confusing. Just give me a sequence of numbers. If it's logical, great. Make it logical. If you want that to be a data frame, each element is going to be a data frame, and you want to just collapse all of that list into a single data frame, use mapdf. You can use two inputs, right? So I've sort of here said, give me one input. If you have input 1 and input 2 and you want to apply a function of that, you can do that too. There's a function for it, map2, map across two inputs, and you can map across two inputs and get a number, and map across two inputs and get a data frame. We're not going to worry too much about the map2 variations. If you've got 3 inputs, there are solutions for that too. It gets a little bit confusing. Most of the time, try to keep it simple, and just using map will get you an awful long way. All right, so the process that I use, especially when you're just getting started with this, a process that I recommend is to not like sit down and think like, cool, I'm going to write a function and then map. That's maybe not the approach that I would use, right? I think what's a little bit more clear is to say, I've got one line of code or one code chunk that now I know I need to iterate a couple of times. I need to change an input and then copy and paste this again. And I would start by saying, here is my clean code chunk. Now let me turn that into something like a loop. so that I can define an input and an output and the thing that I want to iterate across. And now I've just moved that code into a for loop. Now I'm going to turn that code inside of a for loop into a function and try to keep my for loop going with a function. And then finally, once you've done all of that, switch it up and have an input, a map statement, and your function. And that's going to be sort of the cleanest thing. But again, this is not the sort of process where you want to start from scratch and just start writing functions and map statements. That's going to be really tricky. Build things up a little bit at a time until you start to get comfortable with this process. And this, again, eventually, with time, with practice, you'll get used to saying, all right, I need to write this function, and I'm going to skip the for loop step. I'm not going to worry about that. I'm just going to go straight into writing maps. In the meantime, write for loops if you need to. Try other things if you need to. It's gonna be all right. All right, so I've mentioned now lists. Lists, we got to talk about lists. So most of this course is focused on data frames. Data frames being you've got a column of numbers, another column of numbers, a column of factors, a column of categoricals, a column of numbers, whatever. But it's a column. There's same number of rows in each of those. It's all sort of nice and like a little data rectangle. And that's great as long as you're dealing with things that can be stored in data rectangles, okay? But life isn't always that easy, and R has ways where you can store things that aren't just the same kind of thing or with the same kind of length. So in this example, I'm saying, let's just see what we can do, right? So I've got a list. The first one is a sample from a normal distribution. The second one is first my first name and then my second name in a character vector. And then just to see what happens, I'm using a built-in R summary function, which is heartbreaking, and I'm applying it to a sample from a random uniform, okay? And this list has named elements A, B, and C, and it's keeping track of that sample, it's keeping track of my name, and it's keeping track of this. This is absolutely nothing like a data frame, right? There's no way that I could say, like, give me the rows and give me the columns. It just doesn't make sense here, okay? But what's helpful is that lists, then they can store anything, and given that flexibility, you can keep track of different kinds of output. You can try a variety of different things. In the context of a loop function, or in the context of iteration, you can have an input list that's a complicated input list, and you can have an output list, and that can be complicated too. That's all fine, right? It's just the lists are going to be a way to keep track of something really arbitrary. Now, I do want to be kind of clear, because this is where it starts to get a little bit weird, and it's about to get really weird. And this is where it starts. All right. So data frames are actually a very special kind of list, right? Like in the background, we've been looking at like these nice little data rectangles, but what R is really doing in the background is saying, like, okay, this is a list. You're giving me a list. I've got a vector of numbers. I've got a vector of character, a vector of numbers, a vector of logical, whatever. All of those are vectors. They all have the same length. And if you tell me in addition that this is a data frame, I'll think of it as a list in the background, and I'll just show you like data frames, nice little data rectangles when we're working on things. But this is sort of, again, in the background. R is trying to just keep track of everything as a list. Okay, so that's sort of step one. Data frames are lists. Great. So then a list can store anything, and a list can even store a list, right? So I could have a list that's got like some numbers and then some characters, and then maybe the next thing is a list, and it's got like the first object and the second object and the third object and fourth, right? It can be a list inside of a list. And so if I have numbers and numbers and then a list, but that list has the same length as the numbers and as the characters, maybe that's still a data frame, right? If a data frame is just a list, and I've got numbers, characters, and a list with the same length of everything, could I just turn that whole thing into a data frame? Yes, you sure can. And it turns out that this is just a really, really great thing to be able to do, especially in the context of iteration. Because if you have an input list and you want to set that next to an output list, you can just put them both inside of a data frame. And now you don't have like an input list over here in your environment and an output list over there in your environment. It's all just like floating around in exactly the same thing. It's not floating around. It's all stored very carefully in the same data frame. And you've got your inputs and your outputs sort of side by side, very nicely organized. So list columns in data frames turn out to be really useful. And I can hear you thinking like, Are you serious? And yes, I absolutely am. This is one of the more powerful tools when it comes to doing iteration for problems that come up a lot in statistics and a lot in data science. So if you have your input list in a data frame and then you map your function to each element of that input list and then store the output next to it, you can sort of continue that process on. You could say, here are my numbers, here is some list object, let me apply something to that, and now let me apply something to that or apply something to that, and I can just keep all of this stuff nice, neat, organized, everything's tidy. We don't have to keep track of input over there and a for loop index and an output going over that. It doesn't matter, it's all in a data frame. And even more than that, if you're keeping track of everything in a data frame, then the usual kind of tidyverse things work. You can select columns even if they are list columns. You can filter based on things. You can just go wild doing tidyverse manipulations as long as you're keeping everything in that list column structure and in that data frame. And that's really fantastic. So one of the ways that you're going to see that this actually works out is in your list column, in your data frame, you could have a list column, and that list column could itself be a data frame. And that's I can hear you sort of thinking through the computer, like, that seems like a wild thing to do. Why would you ever do that? The goal, or the reason that you might want to do that, is to say, if I have a data frame here and a data frame here and a data frame here, maybe I'm looking at a hierarchical data set. Maybe what I know is information in one geographical unit and the next one and the next one. And I've got a bunch of data for the first thing and a bunch of data for the second and a bunch of data for the third. Maybe, and this happens a lot, you need to do an analysis on the first data frame and on the second and on the third, and you want to store the results of each of those analyses side by side. And you can do that. And once you've got those analyses, you can extract summaries. You can do other things that you need to, all in the context of a nice organized data frame that's going to make it possible to sort of get quick summaries of the things that you care about. So that's going to be really great. I'm excited about it. I hope you're excited about it. Let's jump into a screencast and see how all of this works. All right, I'm going to go ahead and jump in on iteration and list columns. Usual framework. I'm inside of an R project. I've got an R Markdown document open. I'm loading some packages and setting some options, and we're going to go from there. What I'm going to get started with is a very short discussion about lists. And the idea here is to revisit the idea, or to at least introduce the idea, that lists can store all kinds of things. So we have seen in the past, we've created like numeric vectors and character vectors and other things like this. What I'm going to drive home now is that really inside of a list you can store anything. So you can put anything in a list. Okay, fantastic. So what I'm going to do is, we've seen things in the past like a numeric vector that is, say, the numbers 5 to 8. Okay, and we've seen things like a logical vector, which is, let's say, true, true, false, true. And if I wanted to put both of these into a data frame, I would need to make sure that I have the same number of elements in both of these. And here, I'm going to be clear that for a list, you don't necessarily have to do that. So I'm going to add here a false and a false, just for fun. There are some other things that we haven't seen as much of in the past, but suppose I've got something like a matrix. And the matrix that I'm going to use is, again, it doesn't really matter. We're not worried about what matrices are. I don't care all that much about that. But I'm going to say I've got the numbers 1 to 8, and I've got 2 rows and 4 columns. Call equals 4. And then I'm going to create a summary, and let's just use R's summary function. I hate the summary function, but it shows up sometimes, where I've got a sample from a normal distribution of size 100. So again, let's just sort of take a look at each of these things, just to be clear that they're different, right? So my vector has 4 numbers. My logical has 6 numbers. My matrix is a matrix with 2 rows and 4 columns, and there's no way that I could put that in a data frame next to any of these things. It doesn't make a lot of sense. And summary here is a summary. It's sort of saying that of the 100 random normals that I generated, the mean was minus 0.07, the minimum was minus 2, the maximum was positive 2, whatever, that's sort of the summary. Again, there's no way I could put all of this into a data frame, but I can put all of this into a list, and that's what I'm going to do now. So Okay, I need to sort of list all of these out as separate things. And I'm going to save this as L is my list. And L is not a great variable name. We're not going to use L beyond this. So we're going to take that L and we're going to move on. All right, so again, what's going on inside of this? I'm just going to check what happens if I print. Okay, so the list now has given me a way to store all 4 of these objects that are really different from each other. The first one is vec numeric. It's named here. It's also the first element. I've got vec logical. I've got my matrix. I've got my summary. And I can do things here like you might want to do. You can access different elements of this list. And so this R $ notation, which I still don't love, I very clearly don't love this, but you can use this to access something that exists in a list. You can also use the sort of double bracket notation to say, give me the first list element, and it's going to give me that. And you can use sort of a combination of these two things. You can put 2 double brackets and then quote the name of the thing that you care about, numeric. Okay, and that's all going to give you the same stuff, right? And then once you're sort of dealing with this, right, that's a numeric vector, and so you can do things like give me elements 1 to 3. Okay. You could also take the mean of that, and it's going to give you the mean of that, right? Like you can do, if you are accessing individual elements of that list, you can do whatever you would normally want to do to individual elements of a list. Okay. What I'm going to do now is we're gonna take a look at another list, but we're going to start doing for loops and see what we can do here. So let's look at a for loop, and to do this, I'm going to create a new list. And the new list that I'm going to create is one we're actually going to deal with. So I'm going to name this something that I care about. It's a list of samples from a random normal distribution. So I'm going to list out a few of these things. I'm going to say A is R norm, and I'll give this size 20, and let's say mean is 3 and standard deviation is 1. Okay. And then I'm going to do a B, a C, and a D. And I need to update these. B, C, D. And let's just pick some different numbers here. So this will be 5 and 0. Let's make one a large mean and 0.2. And then let's go negative. Let's be -3 for once and maybe 1, right? Sort of the opposite of this one. Wow. I don't know, opposite. Anyways, whatever. I've got a list now with 4 elements, A, B, C, and D, and these are each samples from a normal distribution, okay? And they don't all have to have the same number of entries. They, maybe just to be clear, I'll give this one 30 and this one 40, just to sort of drive home the point that this isn't something that I could really easily put into a data frame, okay? And so what I want to take a look at now, I could, for example, do like list norm 1, and that's going to be the first element of my list. I can print all of these and see A, yeah, that's about right, 3, standard deviation 1, B, this has a larger mean, this is negative, right? It sort of looks to be about right, and my list has a bunch of different things in it. Now, I'm actually going to sort of pause and get my old function. And by pause and get my old function, if you remember, in writing functions, we spent some amount of time saying, let's write a function that, given a vector, computes a mean and a standard deviation. And I'm not going to rewrite that function now. I'm just going to go back to writing functions, and here's mean and standard deviation. It was a function of x. We have a check. You have to be numeric. You have to have at least 3 numbers to compute a mean and standard deviation. At least I'd strongly prefer that. And then it computes the mean and the standard deviation, and it spits both of those things out as a tibble. So I'm just going to copy this function. We're not going to reinvent the wheel. We're just going to reuse the wheel we invented last time. Now the point that I want to make here is I can apply that function to each list element, right? So I can, inside of here, let's just sort of, take a look. I've got my list of norms, and I can look at the first one, and I can look at the second one, and I can sort of look even at the third and fourth one, and this is going great. 3, 4. Now, if I did mean and standard deviation on the first one, did I not? I didn't even get Tibble in here yet. All right. I can get mean and standard deviation of my first one, and I can get the mean and standard deviation of the second one, of the third one, and of the fourth one. Let's just run all of this, right? So I get 3 and 1 for my first one, and -1 and 4 for the second one, and 10 and 0.2, -3, right? So I'm getting things that seem to be about right. But I'm also sort of getting into a framework now where even though I have a function, I am having to apply that function to each of my list elements by copying them 1, 2, 3, 4 times. And if this is 4, you might look at it and say, that's fine. If it's 40, you definitely don't want 40 lines of code that just change 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not something that you want to do. So this is where we're going to start moving into the idea of a for list. So let's use for list, a for loop. So in some sense, I've already got my input list, right? My input list is this list rnorm, and I'm gonna make sure to save my output list. And if I just wanted to create an empty output list, I'm gonna create a vector of class list, and I want it to be just as long as my input list, no more, no less. So this is gonna be length 4. So now if I look at output, it's a list. It's list 1 is empty, list 2 is empty, list 3 is empty, list 4 is empty. It's got 4 spots, just nothing in it. And what I'd like to be able to do is something like output of 1 is equal to equal to mean and standard deviation of list norm 1. So now if I double check what's going on inside of output, the first spot is a tibble. It's the mean and standard deviation. So that's looking great. But I don't want to just copy and paste this now 4 times and then make sure to change a 2 and a 2 and a 3 and a 3 and a 4 and a 4. That's not what I want to do. So I'm going to use a for loop instead. And now I'm using I as a placeholder here. I is going to be the thing that goes from 1, 2, 3, and 4. So I want I in 1 to 4. And the first time through, I is going to be equal to 1. And the second time through, I is going to be equal to 2. And the third time through, it's going to be 3, and so on. So I just need to keep track of everywhere my index changes. So here and here, I got to keep track of both of those, okay? But if I've done this correctly, then instead of having, output 1 equals mean and standard deviation, list as list norm 1, and so on, hopefully without copy and pasting this, it's just going to do this the first time, I equals 1, and then 2, and then 3, and then 4. So let's check what we got going here. And now I'm going to just see what's happening in output. This is cool, right? So I could, like, you can double check, is this the right mean and standard deviation? You could go back and double check at least against these things. It looks to be about right? My input list was a normals 3, 1, and -1, 4, and 10, and 0.2, 0.1, something like this, and -3 and 1. This is computing the mean and standard deviation for each element in my list, and I am thrilled about this. So I'm gonna, just to be clear, I'm gonna save and commit, because I've written a for loop and I'm really feeling great about it. So commit, I wrote a for loop. Yeah, I did. Good work. All right. So even cooler, what we're going to do next is map some things. So let's try map. Okay. So what I'm going to do now, again, is the whole thought process of the map is, instead of saying like, here's my input list and here's my output list, and now I'm going to define a for loop structure, and I'm going to do 1, 2, 3, 4 times through that for loop, and I'm going to apply this line of code every single time. The idea for map is, if I can take my map as a function and give it an input list, and here my input list is norm, and I can give it a function that I want to apply, mean and standard deviation. Hopefully this is just going to do that same process without having to keep track of indices, without having to do anything else. So let's just see what happens. So if I just run this, if I just run map 1, 2, 3, 4, this is what it spits out. Same stuff, same as what output had been. It's a little bit more careful. Instead of just saying this is 1, 2, 3, 4, it's saving the names even of the input list object. So I have output A, B, C, and D, and A, B, C, and D, the output here, is the same as it would be if I ran this loop. So if I just save output equals map over this, these two things, these two code chunks are going to be exactly equivalent to each other, with the distinction that map is keeping track of my input names here. It doesn't have to, you can tell it not to, but it will by default keep track of that. So this is pretty great. And to, I guess, to even be a little bit more clear, one of the things that's nice about this is, you know, what if you want a different function? So instead of, say, output, I have the mean and standard deviation. What if I do output is map across the elements of list norm, and let's try median, right? This is a different function. I just want to try a different function applied to each of these things. Now let me check what output is. Well, it's giving me the median value instead of that, the mean and standard deviation. So what's cool here, let's try something else. Interquartile range, and take a look at output. The interquartile range is 1 and 6 and 3 and 0.7. You can do standard deviation. You can do whatever you want to. You can map any function that you want across this input list. And this is, we sort of said previously in writing functions, that you can have functions as input to other functions. And this is exactly where it's relevant, right? What I want to do here is map across list norm some function that I'm supplying. And that can be a function that you wrote, mean and standard deviation. It can be a standard function. It can be whatever function you want to apply, simple, challenging, whatever. You can apply functions to any element of your input list. And this map statement should be pretty clear here. Hopefully this is going to work pretty nicely. I'm going to go ahead and knit because I might as well. Okay. What I'm going to do now is, I wrote a map. That sounds weird. Cool. All right, so what I'm going to do now is just look at a couple of map variants. And what I mean by map variants is, in the first place here, suppose what I have is, let's keep this one for now. So I know when I run this that I've got A, B, C, and D. Right? That's sort of the collection of numbers that I've ended up with. And right now, this is a list. And having this as a list might not be exactly what I want to do. So I can say, what if it's a double instead, right? So I'm gonna try this, and it's gonna give me now not a list, well, a fancier, different sort of version of a list. It's giving me a vector in the same way that if I did 5 to 8, it's going to spit out 5, 6, 7, 8, not as a list. Here, the medians are just listed as numbers, and they're going to sort of show up as numbers rather than as lists, and you sort of get rid of something that's maybe a little bit challenging there. I think you can here say ID is something about input. Let me just double check. Did that change anything? No, not here. One thing that you might do though is, let's take a look at the slightly more complicated example. So here, if I run map list norm, mean and standard deviation, now I can't call this double. These aren't individual numbers, and if I tried to make this individual numbers, it's not going to be particularly happy with me, right? So if I said try to make sure that this is a double, it's going to say no, it's not that, right? So let's try something else. Let's just make this a data frame. Each output of mean and standard deviation is a tibble. So if I map and I tell it to expect a data frame, what it's going to give me in the end is that collection of data frames. It's going to say, here is your first data frame, and then it's going to bind that to the next data frame, and bind that to the next data frame, and bind that to the next data frame. So instead of, again, a list of data frames, it has taken each individual data frame and collapsed it down and made the output a little bit easier. And here, I think, keeping track of ID makes maybe a little bit more sense. Take a look. Yeah, so here if I tell it to keep track of what the input ID names are, so the list names are A, B, C, and D, and I am telling this, put those A, B, C, D names into a column called input. Here is my input column, here's the name of my input list, and I'm keeping track of the mean and standard deviation each time, okay? Okay. We are blazing through this. Hopefully things are still, you're following along with me. I always feel like doing this kind of thing, it seems like super straightforward, I think, if you're watching me code, but it can also be really confusing if you're like not thinking through the steps, or when you start trying to look at things that are a little bit different. So I am moving kind of quickly here, but I hope it's going smoothly. I'm having a great time. I hope it's going smoothly for you too. All right, now what we've talked about up to this point is we've got for loops, we've got map statements, we've got lists, and one of the key ideas here in this video is keeping track of everything so that you don't, in your environment, have a list of norms and an output, and somehow I've got I floating around from my for loop, and I've got some of the other objects that I created. I don't want to have all of this stuff. I don't want to have to keep track of like output goes along with this input list and that's where it came from. Really what I would like to be able to have is something that keeps track both of my inputs and my outputs at the same time, and that's where list columns come in. So now we're really getting into it. List columns. Okay. So what I'm going to do first is create a data frame that has a list column in it. So I'm going to call this my list column data frame, and it's a tibble. And what I'm calling my tibble is name is, let's just give it the names, A, B, C, and D. And the sample column is going to be that list of samples that I generated previously, list of norms. Okay. Now, I just want to be clear here. What we're dealing with is a data frame. This is, I created it using Tibble, and it hasn't even noticed that anything is strange here. If I just print this column, it looks a little bit different now, right? So the name here is a column. The first row in name has A, and the first row in samp has that first element of list norm. It's a vector of class double of length 20. That's the first thing that's showing up in my sample column. The second row in my data frame is B for name, and then the second element of this list for sample. It's a sample of length 30. Next one's 40, then we're back to 20, right? But this is, I guess, sort of to be clear, what's helpful about this is that, like, sure, there's a lot of stuff going on inside of here, but the printed tibble is trying to make my life a little bit easier. It's just telling me, like, whatever, you've got a list in this column, a named list even, you've got a list in this column, and this element is a collection of doubles with length 20, and so on, right? And even better than this, you can do things with this list column data frame that you might want to do. So let's first just double check. Let me just sort of pull first the name column, it's A, B, C, D, and if I pull the sample column, let's make sure this does the same thing that I want it to. That sample column is still that same list that I started out with. So the list column data frame has everything that I need it to have. It's just a more compact way of looking at things. And again, it's a data frame. You can do whatever you want to. So if you wanted, for example, to filter, name is A, well, you can do that, and you're going to get a tibble back, and you're going to get the tibble that has this row in it, right? So we're still sitting around with our data frames. Now the other thing that you can do here is let's try some operations. Okay, and when I say operations, I mean, suppose I want to take the mean and standard deviation of the first element of my sample. So this is going to be a little bit strange at first, but sort of follow me along. So I've got my list called data frame, and I'm going to use the $ just because it's a little bit easier in this case. And again, this $ is the same as pulling out that column, and it's giving me a list, right? So I've got A, I've got B, I've got C, I've got D. And it's a list, so I can do the same kind of list things with it that I would normally do. I can use list called df, $sample, bracket 1 to get the first element of my list column. All right, and now suppose what I want to get is mean and standard deviation of this thing. Now again, list called data frame is a tibble. The second column, the samp column, is a list, and this is getting me that list. and then these square brackets is getting me the first element of that list, and now I am applying mean and standard deviation to that. And this is that same 3.02 that we've seen a whole bunch of times, right? That's the right thing. Now I might, even more than this, say, suppose I wanted to apply this to the second one and the third one and the fourth one all the way through, right? Like we could do that, and let's, I'll sort of do 2, okay, right? It's doing the right thing. So can I just map, right? Keep in mind, back, 7 minutes ago, when list norm was our list, we applied mean and standard deviation to each element of list norm. I guess it's maybe a little bit farther up here. We said, here's my input list. I want to apply mean and standard deviation and save that output, okay? So let's try to do something like that. Now again, the list that I want to iterate across is here. This is my full list. It's got 4 elements, 1, 2, 3, 4, and I want to map across this column as an input list. That's the thing that I need to map across. And what I'm going to do is mean and standard deviation. So we're getting there, right? So now, I guess when I say we're getting there, what I mean is I have a data frame with a list column. I'm using that list column inside of a map statement, and I am applying this function to each element of my list column. Okay, it's getting, like I say, it's getting a little bit weird. But the thought process is the same as it was up here when the list was just floating around in my workspace, right? Now it's a list column inside of a data frame, but I'm still mapping across each element of that list, and I'm using the same function each time. So, last step of what gets weird is, suppose I wanted to keep track of this output, but since I've got stuff floating around in a list, I don't want to have, in a data frame, I don't want to have like my data frame with a list column and then output just sort of stored somewhere outside of my data frame. What I really want to do is apply this function to each element of my list column and save that output inside the same data frame. So can I add a list column? Question mark. Yes, I definitely can. So the way I'm going to do this is the same way that I would add any column to a data set. If I have a data set and I want to do an operation on a column and save the result, that's a mutate problem. It's way back, a long time ago, back when we were saying like, all right, I've got this column and I want to add 2. Great, that's a mutate problem. So I'm going to start with my list column data frame, and I'm going to mutate, okay? And the mutate is going to be to map across a column and add this function, okay? So I want to map across a column in my data set and apply the same function. Now, in mutate, I have to say, well, what's the output that I want to save this? So I'll just call this, I'm creating a summary column in my data set. And the way I'm creating that is by mapping across the sample column. I don't have to do list column $ sample anymore, right? I'm inside of a mutate statement. So this mutate knows that I'm working on columns inside of this. I don't have to do list column anything. I want to map across a column in this data set. And the thing that I want to map across this is mean and standard deviation. And that's going to be my summary, okay? So let's check what happens here. This is fantastic. You might be thinking, is it fantastic? Yes, it is. The reason that it's fantastic now is that I have in one data frame, I've got the name of everything that I care about. I've got the sample list that I started out with, and I've got the result stored as a list here, right? So I know what mean and standard deviation does is it creates a tibble with the mean and the standard deviation for my first sample, for my second sample, for my third sample, and for my fourth sample. This is cool. This is really handy. And I guess it's handy enough that I'll just say, let's create my list called data frame, overwrite that with the result of this mutate statement. And let's play around. Let's try something else. Suppose I did map df here. that doesn't look great. It's spitting out the right numbers, but it's sort of giving me this summary $ and something here. That's not so great, but let's try something else. What if I did medians is map across sample the median function. That's still also a list, but it's a list of doubles. So maybe I could do map double here. Let me check. Right. So again, the process that I'm using here in just a few lines of code, and once you get used to it, a few relatively transparent lines of code, is to say I've got a data frame with these names in this sample, and then I've created a mean and standard deviation summary, and also computed the median for this element, and then for this element, and then for this one, and then for this one. I don't lose any information. I don't have a bunch of vectors floating around where I have to keep track of how everything's going. Everything's right here, and I can just look across my rows and know what's going on inside of this data set, and that's really great. Okay, so I am going to knit here. I feel like I've done, gosh, we've made a lot of progress. So let's see, what did we do? Bunch of stuff. I think we did, what all did we do here? Well, we did, let's say list columns. Yeah, we did list columns. There it is. List columns. Okay. That's, man, I'm feeling great. All right, so the list columns that we looked at, I've got this nice little data frame. Everything's nice and organized. It's all tibbly up and everything's really, really nice. But you might sort of be sitting there thinking to yourself, it's sort of contrived in the sense that the list that I started out with was a list of random numbers, and how often does that actually happen? And so what we're going to do now is look at an example that is a little bit less contrived and try to do similar kinds of things. Okay, so what I'm going to do now is, what did I call the last one? List columns. We're just going to do weather data. So it's been a while since we looked at this. When we were talking about visualization and numeric analysis, we spent some time on this weather data frame, and we're gonna revisit this. The way I'm gonna create this list column is the following. So let's get our list columns. Okay, so I've got weather data frame, and I'm gonna create weather nested or weather nest data set. And the way I'm going to do this is to nest some of the observations in my data set. So I'm going to use this nest function. And what I need to create is the columns that I want to nest within whatever columns remain by that. And so here I'm going to create a new column called data, and it is going to result from nesting everything between date and tmin inside of each of these. Now again, I guess sort of before I even run this code, I want to take a step back. Again, in this data set, I've got Central Park all the way down, first 365 days. And then I go Waikiki the next 365, and then Waterhole the next 365. And within Central Park, I've got these four columns: date, precipitation, Tmax, and Tmin, and those are data that exist for Central Park. And then next to Waikiki, although Waikiki is repeated 365 times, there's like a little data table that goes along with this, right? So what I want in the end is one data frame for Central Park, one data frame for Waikiki, and one data frame for Waterhole. And so I'm nesting date, precipitation, Tmax, and Tmin for each of these. So I'm going to nest everything date to tmin, and what I end up with is something that is exactly like that. So here I've got name stays the same, right? Everything is Central Park. The actual ID identifier is there, and then my data column in my new weather nest data set, that data column is a tibble with 365 rows, one for every day of the year, and 4 columns, one for date, precipitation, Tmax, and Tmin. So this is cool. I've got this kind of a thing, and I can even do the same things that I had looked at before. So if I do weather nest and I pull, say, name, it's going to give me 3 observations. And if I do weather nest and I pull data, it's going to give me a list with 3 entries. And the first entry is a data frame, date, precipitation, Tmax, Tmin. Second one is a data frame, date, precipitation, Tmax, Tmin. Third one's a data frame, and the first one goes along with Waikiki. The second one, Central Park, and then Waikiki, and then Waterhole. And you can do things sort of like the following. I could do, again, although I don't love it, weather nest, $data, and let's look at the first element here. This is just the tibble. This is the tibble for Central Park. That's everything that's going on inside of here. And you might, for example, want to perform some operation on this, and we'll do that in just a second. And then you might perform some operation on the second one and on the third one, right? So this is an example where your list column is not just some like trivial thing that you came up with. This is something that actually makes sense and that you might run into. So let's think about what kind of an operation we might want to do. So suppose I want to regress Tmax on Tmin for each station, right? So the idea is Tmax predicted by Tmin for each station? And I'm sort of here, there's some background statistics knowledge that I'm assuming, and if you're not real sure what's going on with regression or why you would want to do that, don't worry so much about that for right now. Really, the goal that I want here is to say I can do regression for a data set, and really what I'm interested in here is can I do that regression for each of these data sets separately? That's what I want you to focus on for now is that computational problem. Not trying to understand what regression does or what it's producing, but just can I take a data frame input and run regression on that data frame and like store the results of that in something else. So let's take a look at how I might do that. So if, for example, what I wanted to do was regress, let me just sort of make sure I can do this. Let's do weather nest $data 1. So that's a data frame, right? Now suppose I wanted to do a regression of Tmax on Tmin here. So I'm going to do lm of Tmax against Tmin, and the data set that I'm interested in is whatever that thing is, right? I've got here weather nest data frame 1 is the data set that I'm using, and I am using the linear model command to regress Tmax on Tmin. Again, don't know what I'm talking about, don't worry about it too much. But if I run that regression, I find this is the result. I've got a formula, I've got coefficients, an intercept, and a slope, and that looks about right. And I could check like what happens if I change this to 2, and what happens if I change this to 3, and I'm getting different things here. So this works. This works. But I want to sort of make this a little bit easier. So one of the things that I often do is, again, starting from a working example like this, where I know I've got like an input that's going to be changing 1, 2, 3, or even better, an input object that's going to be changing a data frame 1, a data frame 2, a data frame 3. What I'd really like to have is a function that takes that input as an argument and spits out the result. So let's write a function to do this regression. So the way I'm abstracting this, the way I'm thinking about this, is that my weather lm function is a function of a data frame, and that data frame is going to get used in the following way. So I'm still going to fit a linear model Tmax against Tmin, and the place where I want that data frame to show up is as the data argument. So here, I'm just going to say that data is equal to whatever the df argument passed into this function might be. And I'm going to double check that this works in the following way. So now I've got a weather lm function, and I'm going to apply that to the first entry in my data set. And it's doing the same thing. And this is a simple example of a function, a simple example of what you might use. But I've got a function now that, given an input element of a list, computes a linear model and spits out the result. And I'm not doing any checks. I should, probably do, like, if df isn't a data frame, this should break. And you might do some checks on the size of the data frame. That's not my goal right now. But this works. Okay. So the next thing is can I apply this weather lm function to the first one and the second one and the third one? And I could do this using a for loop, and maybe I will, just to sort of be clear here. If I said that output is a vector of type list, and I've got 3 data frames, what I could do is write my for loop for I in 1 to 3 data frames. I want output of this index to be weather lm weather nest data of that same index. Okay, so I can get rid of these things now. So I've got my output here. Again, when I is 1, I'm going to get the first element of this list, run weather lm on it, and save the output here. So let's just check. Did that work? I got 1, 2, and 3. Fingers crossed. These are about the right coefficients. These look to be about right. These look to be about right. All right, so we're doing well. Okay. Now, if we can do this in a for loop, we can do this using a map statement. So let's try that. What about a map? Okay, same idea. I've got an input list that I care about. So let me just sort of start at the beginning. I've got weather nest, which is a data frame. And if I look at, it's a data frame with 3 rows, Central Park, ID, and data. Data is a list column, and that list column has all of the information on precipitation, Tmax, Tmin, and something else for Central Park. I forget what my 4th variable is here. Date, obviously. I've got that data set for Central Park in this column. I've got that Central Park for Waikiki as the second element of this column in that data set. For Waterhole as the 3rd element of my column. So weather nest date is a list where each element is my data set, and I want to do a map across that list, and for each of those things I want to apply my weather lm function. So now I've got an output object, and that output object is this linear model, this linear model, this linear model. Still working, right? So what about a map in a list column? This is just fantastic, I think. So what I'm going to do next is exactly that. What I'd like to do now is say, can I still map, but I want to add the results of this as a column in my weather nest data set. So I've got weather nest, again, name, ID, data. I need to add a column that stores the model results. Adding a column is a mutate problem. Mutate. I am adding a models column, models. Yeah. All right, I'm adding a column here to store the results of this linear modeling. And what I'm going to do is the same thing. I need to map across a column and apply this function each time. So I'm going to map. I don't have to do weather nest. That's sort of implied by this tidyverse process. It knows that I'm sitting inside of a data frame with a data column. So I'm going to map across the elements of that column, each element of that list. And I'm going to use weather lm each time. And now what I get at the end of this is a new data frame. I've got names, I've got IDs, I've got data, I've got models, and maybe I'll save this real quick. And we can just double check, right? Now I've got that extra column floating around, in weather nest of models is that list of linear models. So this is really great because in my weather nest data set, I've got rows now, Central Park, I've got the data that goes along with that, and I've got the linear model that results from that fit. Now, this, again, I think is a little bit less contrived than doing something like, oh, I've just created 4 random numbers, right? Or 4 random samples, and I'm computing a mean and standard deviation for each. This is telling me, and we haven't gotten into linear models, we haven't done anything beyond that, but now I know that I can at least if I've got data, weather data nested within stations, I can fit a separate linear model for the first station and the second one and the third one, and then I could probably start looking at the results of those linear models as well. I can start doing other things based on that. And I think that is where we're going to leave things for now. There's a lot going on here, right? I mean, we've covered in this lecture a lot of stuff. We've talked about lists, and then we've sort of assumed that we know how lists work and started using lists as list columns. We've done for loops and map statements, and then given some list columns, we've used map to create more list columns. Like we've done an awful lot of stuff here. It's not obvious, it's not easy, it's not straightforward. Play around with this, make sure you sort of understand some of the choices that have gone along with it. Try some things yourself. Because this is again really one of the important foundational tools when we start looking at things like I need to run simulations, or I need to do some data science kinds of things like bootstrapping or cross-validation or some other kind of an analysis. Like this is really, really helpful, but it's a really big shift in how things work. I guess the last thing that I'm going to say on that is long time ago when we were talking about exploratory data analysis, we said that a lot of what you might need to do when it comes time to summarize data is to do group by and summarize. And we said that that would get you a really long way, but it wouldn't get you everywhere. So here, in this case, if I wanted to compute the mean T max or the mean T min in each of these locations, that's an easy thing to do. Group by, summarize, compute that mean for the first group, the second group, the third group. There isn't really a way with group by and summarize that you can get to fitting a linear model and some more complex summary of the things that are going on inside of this data set. So really sort of where we are now is pushing past some of the things that we have done in the past, but trying to still, I guess, kind of do it in that same framework. We're still trying to stay within the tidyverse. We're using tools. Purr is like the last package in the tidyverse that we've gotten to, but it's a really important one, and all of this is really neat. So stick with it. There's cool stuff, and I appreciate your work and following along. Thanks.